All right, let's go back to social media and get some questions, more questions answered.
All right, science time. How about that? Let's. We have an interesting science question over here, and this is kind of. I was interested in this science question over here. Actually, if we can. Oh, there we go. All right, cool. So this is an interesting thing because it's got a graph on here. You can see it, but it says, what is the wavelength, amplitude, and frequency of this graph right here? So it's got like a dotted line right there with 0 in the middle, and then 0.04 or 0.4 on the top and 0.4 on the bottom.
Yeah, okay, great. So we were yesterday talking a little bit about sound waves, and in sort of a rush to wrap up the show, I didn't get to talk about this as much as I wanted to, so this is great. So a variety of different energies that exist in the world take the form of waves as they travel through mediums. Some really great examples of that, the two most obvious, are light and sound. And yesterday on the show, we talked a little bit about how light works, and we talked just a little bit about frequency related to light. But I think I'll stick with sound this time because I think it's just maybe a little bit easier to understand. But we can imagine that a sound wave is just a sort of a set of vibrations moving through some kind of a medium. In the case of humans, we hear sound through air, right? If you're a whale, you can hear sound through water. But when I make sound, like when I talk, I'm shaking my vocal cords in my throat or my larynx, and the vibrations of my vocal cords are vibrating the air, and then those vibrations are traveling through the air to you at home. And there's a couple pieces there, right? So there's the sound of my voice, kind of how high-pitched or low-pitched my voice is, and then also the volume of my voice. I can talk very quietly, and I can talk very loud too. And if I do that, I'm changing the wave pattern that I'm talking about. So I think what we'll do first, if we could jump to my screen, I just want to kind of break down what is wavelength, what is frequency, and I'll also, and amplitude too. So this is a really simple graph that I have here, but I think it does everything that we need it to do. So let's start with wavelength. So we tend to think of wave patterns as patterns like this, rising and falling patterns. And a wavelength, we call these crests and troughs. So we think of this wave shape. The point where the wave comes up to a peak, we call that a crest. And then the low points of the wave here, where my cursor is, that would be a trough. And the measurement of a wavelength is the distance between, or the distance from crest to crest, or trough to trough. So if we wanted to find the wavelength of our example here, even though there isn't really good...
Is it?
Okay, let's do this. If we can jump back to Jeff. Let's jump back to Jeff's screen, and I'm going to direct Jeff to sort of help us here.
All right.
So, Jeff, can you point to the top, to the crest of the wave closest to you?
Okay, here's the crest of the wave closest to
Excellent.
me. Right.
And, Jeff, I can see that on the x-axis there, they've got it marked at 0 meters closest to you, then 2 meters and 4 meters.
Yes.
Where do you think we're at there? Put your finger back on the top of the crest. How far along the x-axis would you say we are?
Let's see.
I would say a half meter. Would you agree with me there?
I would agree, yes.
Okay, so we'll say it's a half meter. And then, can you put your hand on the next crest? Where's the next crest?
Next crest over
Okay,
here?
good. And you see Jeff skipped the trough, which is fantastic. So it's that distance there, Jeff. Can we say that's 2.5? Does that seem reasonable?
Yeah, I'd say 2.5, yeah.
Okay, so if the distance then, and that seems about right. I think that should be right based on what I'm looking at from the wave here. We can say that the wavelength of this wave is 2 meters. Because the distance from 0.5 meters to 2.5 meters, the difference there is 2 meters. So we'll say that this thing has a wavelength of 2 meters. Are we good there, Jeff?
Oh, yeah.
Okay, great. So then the next thing to think about is amplitude. So amplitude is the distance from that midline that sort of divides the wave in half. Jeff's pointing there at the x-axis. And you can see on my screen here, the green line represents the amplitude. So the distance from this midpoint line up to the crest. So in other words, it's half the distance, the vertical distance between the crest and the trough. And then we have frequency. And frequency and wavelength are sort of inversely related. The longer a wave is, the less frequent it's going to be. Because frequency is just the number of times that a wave passes a given point. And I've got an even better visual that can help us out with that. So this is just sort of a simple, it's called a virtual oscilloscope. An oscilloscope is a way to measure waves. This is just a virtual one. So what I can do is I can up the frequency of the wave, and you can see as I'm increasing the frequency of the wave, I'm adding more wave patterns to this picture. Oops, sorry. And the waves are getting shorter. And so again, the wavelength was that distance from crest to crest. So frequency, as frequency goes up, or in this case, as frequency goes down, my wavelength gets bigger. But as frequency goes up, my wavelength gets shorter. So again, frequency and wavelength are inversely related to each other. And I just wanted to quickly mention how this relates to sound. So when we have low sounds, we have long waves. So I'll give you an example of a long wave here. Oh, sorry. Long waves, so waves with long wavelengths, a long distance between the two crests. Those are low sounds. But then high-pitched sounds tend to have high frequency, or do have high frequencies, where the crests are very close together. If I hear a high-pitched sound and a low-pitched sound, and they're at the same volume, they're going to have the same amplitude, meaning the height of the wave is going to be the same. But as the volume of a sound increases, its amplitude also increases. So for me personally, when I think of waves, one of the ways I break it down is by thinking about sound. Higher frequency is a higher pitched sound. That's also a shorter wavelength because it's more waves packed together. Lower frequency is going to be a lower sound and also a longer wavelength because there's greater distance between those two waves. Amplitude, the height of my wave, is really going to describe the volume of the wave. So in the case of this guy on the screen, we said the wavelength was 2 meters, right? The height of the wave is from the midpoint to the top. What is that?
It's 0.4
meters.
Meters.
Okay,
yes.
Great. So the amplitude is 0.4 meters, and then we would want to probably put the frequency at cycles per second. So this graph shows the distance that the wave travels over the course of 2 seconds, which is 4 meters. So over 1 second, it would be 2 meters per second. So that would be our frequency.
Oh, okay.
So just a little bit of mental math there. Hopefully that was semi-clear.
Can I throw out one thing on wavelength?
Please.
Since in trigonometry we teach it and we call it period, right?
Right.
Right.
So in that figure, like you were having a hard time like identifying exactly where the crest was on this, but we could also think about like where does it kind of think about like a starting point?
Sure, the beginning of the period and the end of the period.
Yeah,
0
where would it
meters and
repeat?
2 meters.
Yeah, so
Definitely.
in trigonometry we would just say like it starts at 0. We don't really care about like the
Crests
crest
and troughs.
necessarily.
Sure.
And then I think sometimes it's helpful to like look at like which point is more clearly indicated.
Sure.
Yeah.
Yeah, I guess I always
I just
teach
think
it
we-
as like, where does it start repeating itself?
Right.
You know, here it's going like this, and then at this point, now it's starting to repeat itself.
Yeah.
I
So,
think if you're plotting sine waves, or whatever kind of plotting of waves you're doing, you probably have specific points along the way. A lot of times,
Yeah.
usually use
In the
like a
science class-
5-point method.
yeah, we may be just thinking about a crest and a trough are very definite points.
Right.
But certainly a period is also. So that definitely makes sense.
Well, you could maybe think of it like midpoint to midpoint.
Yeah.
You know, halfway above the crest and the trough.
Right, midpoint between crest and
Midpoint
trough to
to
the next
midpoint.
midpoint is a
Yeah.
period.
And I think interestingly, like, we got the same answer, right? Because it's still that same like when does it repeat?
It should be the same distance,
yeah.
right?
Yeah.